Alright, we're going to learn how to solve and graph two-step inequalities. First, let's take a look at solving them. Alright, we have two steps. Our first one is to use PEMDAS in reverse, just like we would do with equations. So that means we'll add and subtract first, and then we'll multiply and divide. And in most inequalities, those are your only two steps. Alright. Secondly, we want to reverse the inequality sign. That means like the greater than or the less than sign, only when we're dividing or multiplying a negative to both sides of the inequality. Alright, go ahead and pause the video if you need to make sure you have those two notes jotted down. Alright, let's apply what we just learned. Alright, example 1. Copy this down. 2x minus 7 greater than negative 15. Alright, so our first step, we're going to treat it just like an equation. And remember, that means we still have a left side and a right side. I'm showing that with this balance. So, PEMDAS in reverse for our first step. What's our first thing we're going to do? Well, we're subtracting the 7, so the inverse is adding it. And whatever you do to one side, you do to the other. So add 7 to both sides, and negative 7 plus 7 is nothing, so I'm going to mark that out. Okay, I'm going to bring down what remains, the 2x on the left side, I'm just bringing down, and that's still greater than. Negative 15 plus 7, my bigger number is negative, so I know it's going to be a negative 8. And now I'm on my last step for PEMDAS in reverse, which is multiply and divide. So if I'm multiplying by 2, that's right, the inverse is dividing by 2. So I do that to both sides, and x is going to be greater than, negative 8 divided by 2 is a negative 4. And I'm done. And I can still check this. So just like with equations, I can still check it. In this case, though, you're just seeing if the left side is equal to the right side. So you need to know how to check it. So let's go ahead and plug that back in. It would be 2 parentheses negative 4 minus 7 should be equal to negative 15. And now I'm just going to simplify using order of operations on the left. 2 times negative 4 I do first is negative 8. Bring down my minus 7. Negative 8 minus 7 is negative 15. So I know I got it right. It checks. Alright, I want you to notice something. You may have said, well, geez, why didn't you reverse the inequality sign? Because you said that a minute ago. Remember, we said reverse the inequality sign, but what did we say? Only when you're dividing or multiplying a negative to both sides of the inequality. So look back at what we just did, and that negative there on the 8, notice that what we did to both sides was divide by a positive 2, not a negative 2. So just because that has a negative there doesn't mean that we reverse the sign. It's what operation are you doing to both sides? And that's dividing by a positive. So that's why I kept that inequality symbol the same. Alright, well now we're on, that means we're all done with step 2. Step 2 was reverse that if we need to. Well, we didn't need to. Alright, I'm going to jump to example 2. This will be an instance where you do need to reverse the sign. Okay, example 2 reads 15 is greater than or equal to negative 1/4 x plus 6. Alright, so I'm just doing PEMDAS in reverse. So I'm looking at my variable here, and I'm drawing my line down the center. And I need to get rid of the negative 1/4 and the 6. Well, which one am I doing add and subtract with? The 6. So the inverse is minus 6. I'm going to cancel those out. I'm going to bring down my negative 1/4 x. I'm going to bring down my greater than or equal to sign, And then 15 minus 6 gives me 9. Now I have one more step. This is a fraction, so to get rid of the fraction I can multiply by the reciprocal. So if I multiply by negative 4 over 1, or times negative 4 over 1 to both sides, notice that's going to cancel my 1's, it's going to cancel my 4's, and then I'm left with x. Now be careful, because step 2, what did step 2 tell us to do? If we're multiplying or dividing by a negative, what did I just do to both sides? That's right, I multiplied by a negative 4. So since I did a negative to both sides, or multiplied a negative to both sides, I do have to reverse that inequality sign. So on this example, we did need to do that. And 9 times negative 4 over 1 is just negative 36. And we're done. We can always plug it back in to check, but we should know how to do that by now. Let's go ahead and look at how to solve them. Again, pause the video if you need more time. And here's how to solve them. Rather, how to graph them. Our first step to graphing them is make sure the variable is on the left side of the inequality. Okay, because if it's on the left side, it's going to be much easier to graph and easier to explain for that matter. Now let's jot down an example. 4 is less than x. For 4 is less than x, where is the, and I think of this as being like an alligator there. What's the alligator getting ready to eat? The x. So if I rewrite that, that would be x is greater than 4. So when you rewrite it, so the variable is on the left, those teeth need to still be munching on whatever they were munching on. Alright, our second step when we graph is to graph the open dots for greater than and less than, and the closed dots for greater than or equal to, that's part of the equal sign, and less than or equal to. So in other words, you fill them in if you have the equal to symbol there, or you don't fill them in if you don't have it. And notice I put ESS next to my less than symbol. That's just to remind you that that's like a slanted L, meaning less than. If you ever get those confused on which one means greater than, which one means less than, there's an easy memory tool for you. Alright, our third step. So our third step is draw a ray from the dot you just made. The inequality sign points for you. Here's what I mean by that. Think of it as being like an arrow. So if that's your arrow, it's pointing to the right. That means you would draw a ray going like that. If the arrow looked like this, that's part of your arrow. It's pointing which direction? That's right, it's going to the left. So that means we would, next to our dot, or open dot or closed dot, we would have an arrow going to the left. Alright, now let's try a couple. Pause it if you need more time. And here's our first example. Alright, example 1. Negative 3 is greater than x. So here we've already solved it, and now we just need to graph it. So, what's wrong about this? My variable's on the right side. I want it to be on the left side. So I'm going to look at that, put my teeth marks on my inequality sign. It's chomping at the negative 3. So when I rewrite it, it's going to be chomping at the negative 3. Alright, so first step is done. Alright, on my second step, I'm either going to make a number line if I don't have one, or I'm going to use one if I have one. So here, is it an open dot or closed dot? Well, I don't see a mark underneath there, so that tells me it's going to be an open dot. That means it can't equal negative 3. So I'm going to represent that with an open dot at negative 3. If it would have had that, then I would have filled it in. But it didn't. So I'm done with the second step. Alright, remember that's like an arrow pointing for the third step on which way to graph our ray. And which way is that pointing? That's right, it's pointing to the left. So we want to have a ray drawn to the left. So that means that x can be anything that's less than negative 3. For example, it could be negative 3.1, it could be negative 5, negative 10, negative 20, negative 1 million, or negative 1,000. Anything that's less than negative 3, but it cannot be negative 3. Okay, let's try one more example. Example 2. Alright, example 2, we're going to graph 1 is less than or equal to x. And you tell me, where do you think, or what's wrong with that? If you said x is on the wrong side, you are correct. So we want to write x on the correct side, on the left side. And what is that little alligator eating up right now? Oh, he's eating up the x. So right now we're going to reverse it so that he's still eating up the x. And we're done with step 1. Okay, step 2. Is that going to be a closed dot or an open dot? Well, that's part of that equal sign. So that tells me it is going to equal 1. So I can put a closed dot at 1. So fill in your dot. So 1 is a solution. And for our third step, what way is that pointing? If this is an arrow pointing, it's pointing to the right side. So it's everything greater than 1. So let me just ask you, just to see if you're retaining this, is negative 2 a solution? If you said no, you're right. Negative 2 is not part of that graph, so that would be a no. What about 1? Is 1 a solution? Well, it's a filled-in dot, isn't it? So that would be a yes. What about 15? Yeah, 15 is way over there. It's greater than 1, so it's definitely going to be a solution. And let's try one more. What about 1/2? Well, 1/2 would be right here on the number line, so that's less than 1. So that's not going to be a solution. That would be a no. And what the heck, 1.1. Yeah, 1.1 is part of our graph. It's greater than 1. Greater than or equal to 1, so yes. Alright, hope you learned something. And inequalities are awesome for things like you have to be a minimum of this tall to ride this ride. That would be represented by an inequality. How tall are you?